So I'm presenting experiment 2. It asked to draw a wiring diagram for the potentiometer, and it described how it works. So this is my diagram of the potentiometer. It basically acts like a variable resistor, and it contains 3 main components, which is a resistive element, the wiper, and then the 3 terminals. The way the potentiometer works is by varying the position of the wiper. So if you rotate counterclockwise, the resistance between terminal 2 and 3 increase, and the resistance between 1 and 2 decrease. And if you rotate clockwise, the resistance between 1 and 2 increases, and resistance between 2 and 3 decreases. And it's more like an RT. You have an RT, and then the R1 and the R2 are variable, they have variability. So R1 and R2 can equal different things depending on the wiper change, but regardless, it does equal to the total amount of resistance. And that's why there's this arrow here kind of showing like the variability. And so by affecting the resistance, it can limit the flow in a circuit, attenuate a signal, and reduce voltage across certain elements. And when we use a microcontroller, the way we use a microcontroller for potentiometer's position is that in the code there's a variable called sensor pin, and it's created with initial value of 0, and then the positions of the wiper would be the analog input. So when the potentiometer wiper is at the furthest left, the delay is the smallest, and thus it's blinking rather quickly. Once we move the wiper clockwise, the resistance between terminal 1 and 2 increases, and resistance between 2 and 3 decreases, and thus has a greater sensor value compared to initial 0. And this sensor value is our delay, and since it increases, then our delay increases. So this is specifically, we're going to change this to analog 0. Actually, no, this is, let's go back to 2. So this is the second part. This is the same position, except we're starting in analog 2 and digital 10, and we notice how we're in the furthest left, and then as we go more to the clockwise direction, we're increasing the resistance of terminal 1 and 2 and decreasing the resistance between terminal 2 and 3, and we see a time delay in the blinking of the red LED. And so now we're gonna go and change our code to change the analog for 2 and digital 10. So we're gonna upload that, and then we're gonna change it. Oh, actually no, sorry. We're gonna go, we just did analog 2. Analog 2 and 10. So right now we're gonna go back to the original, which is pin number 13 and analog 0. So we're waiting that for uploading. So now it's done uploading, and so now we see that I just changed it to 13 and analog 0, and once again, we notice there's a delayed in blinking. We're at the furthest right now, but as we go counterclockwise, we're increasing that resistance from R2 and R3 and decreasing the resistance of R1 and R2. And now we see that the blinking is quite rapid, really rapid here, and over here it's so fast that it seems like it's constantly on.